Hi there, and welcome to this film, which is all about solutions and their concentrations. It's one of the last couple of films that I'm going to make on the quantitative chemistry topic from the IB Diploma chemistry course, and it relies a lot on a kind of understanding of moles that we've looked at in previous films. But whereas before we've been looking at solids and liquids that we can weigh out, or gases whose volumes we can measure, we're now going to be talking about solutions, so we need to be able to discuss their concentration, and we'll need to know how to relate these quantities that we represent with the symbols C, N and V. This is volume again, but we're not talking about gases anymore. So we're also going to use the formulae of ionic compounds to determine the concentration of any ions in solution. That's a little bit trickier. And then we're going to see what happens when we dilute solutions and see if we can calculate their concentrations once they've been diluted. Okay, first of all, let's start off by looking at what we actually mean by concentration. Now, concentration is a measure of how much substance, measured in moles, I've got dissolved in every litre or every dm cubed of a solution. Okay, so in other words, it's telling us how many moles, the number of moles per dm cubed. So the units are moles per dm cubed, or in other words, moles divided by dm cubed. Now, if you see it written like that, in other words, if you remember the unit, which you're going to come into contact with so often that you probably will end up remembering the unit, then you can figure out that the concentration, C, is equal to the number of moles, N, divided by the volume of that solution, V. And if you can figure out that formula but you don't like rearranging it, you could put these symbols into a triangle, like this one, and then you could use the triangle to find N, which is C times V. You could even use your triangle to find V, which is N on C. Okay, so it doesn't matter how you arrive at these three formulas, but they're all going to be very important to us. Okay, let's have a look at a few simple calculations using these symbols. First one asks us, what is the concentration of a solution containing 2 moles of sucrose in 10 dm cubed of water? Now, it doesn't really matter what sucrose is, because we're told that the solution contains that and water. So the sucrose is dissolved in water, the concentration is equal to the number of moles divided by the volume, and that equals 2 over 10, and that equals 0.2 moles per dm cubed. Why am I giving my number to one significant figure? Because I've only got one significant figure in my data. Find the concentration. 2 capital letters here for some reason. Find the concentration of a solution made by dissolving 2.5 grams of magnesium chloride in 250 centimeters cubed of water. Now, a bit different here because I know that C equals N on V, but I'm not told the number of moles. I'm told the mass of magnesium chloride, which is MgCl2. Now, you can see here, if I'd been asked this question, I didn't know the formula of the magnesium and chloride ions and their charges, I wouldn't be able to get this formula right. If I was trying to find the number of moles, because I need it for here, by doing the mass divided by the molar mass, I wouldn't be able to find the molar mass either, and I'd be stuck. Okay, as it is, I know that there's 2.5 grams of it. If I add 1 magnesium to 2 chlorines, I get 24.3 and 2 35.5s. Where is that? That's 95.21 apparently. Okay, so if I do this here, that's equal to 0.026 moles. 2 significant figures here because I've got 2 significant figures there. So now I know the number of moles of magnesium chloride. I can plug that into there. C equals 0.026. Now I've got to be a little bit careful because my volume isn't in dm cubed. There is 1,000 centimeters cubed in a dm cubed, so this is 0.250 dm cubed, and if I do that on my calculator, I find that this is 0.105 moles per dm cubed. So there's a few more steps there, but I'm using formulas that I should be very familiar with. So really ought to be able to do these questions without too much difficulty. Okay, how many moles of carbon dioxide must be dissolved in 2 dm cubed of water to make a solution with a concentration of 2 millimoles, that's not a typo, millimoles per dm cubed? Right, well, the number of moles is equal to the concentration times the volume. What's the concentration in moles per dm cubed? Well, this is 2 1,000ths of a mole per dm cubed. A millimole is 1,000th of a mole per dm cubed. Okay, so this is 0.002 moles per dm cubed multiplied by the volume, which is 2, okay, and that equals 0.004 moles. Okay, so some fairly simple things there, hopefully, but assuming that we're all okay with that, then let's move on and have a look at something else here. We're now going to calculate ion concentration. Now, it's worth remembering that if I dissolve magnesium nitrate in water, it's not going to stay as magnesium nitrate, it's going to break up into its ions. And if I don't know the formula of the ions, I'm really not going to get very far with this question. Magnesium nitrate would have that formula because this is a 2+ ion and this is a 1- ion. Okay, so once I dissolve it in water, it's all going to split up. It's going to give me 1 magnesium ion and 2 nitrates. I'm trying to find the concentration of nitrate ions only, not of the whole substance. Okay, so the concentration is equal to the number of moles divided by the volume. This is the number of moles of nitrate ions I'm being asked about. So the number of moles of nitrate ions, how's that related to the number of moles of magnesium nitrate? Well, there's 2 of them in every 1 magnesium nitrate. So the number of moles of nitrate is 2 times the number of moles of magnesium nitrate. So now I have to find the number of moles of magnesium nitrate, and the number of moles is equal to the mass divided by the molar mass. Again, I can't find the molar mass here unless I know the formula. So I'm stuck if I haven't learned my ions. But anyway, this would be 2 grams divided by 86.32. These are data book values, remember, because I'm looking them up in the periodic table. Anyway, if I plug that into my calculator, I actually get 0.02 moles. One significant figure here because there's one there, right? But remember, this is the number of moles of magnesium nitrate, so I've got to double it, so therefore there will be 0.04 moles of nitrate ions. Now I know the number of moles, and I can divide it by the volume, so the concentration equals 0.04 moles divided by 0.1 of a dm cubed, because I've got 100 centimeters cubed. So 0.100, again, one significant figure here, so that's going to be 0.4 moles per dm cubed. Just notice something here, that it would be probably clearer to someone marking your work if you wrote that this is the number of moles of magnesium nitrate. So we're going to try, when we're showing our working, to do a slightly better job than I did there of making it clear what I'm doing on every line. Okay, last thing for this film is what happens when I dilute something. Now remember that the number of moles is equal to the concentration times the volume. If I've got a solution in a beaker, there's going to be a certain number of moles of solute in the solvent. If I dilute it, so I put it in some bigger beaker and add lots of water to it, there's still the same number of moles. Okay, so in other words, my original concentration and volume here, C1V1, have to be equal to my new concentration and volume multiplied together, because the number of moles is equal to CV and the number of moles hasn't changed. So C1V1 equals C2V2. That's quite an important formula anytime you see a question about dilution. Okay, we'll use it in a minute, but let's just see if we can do this in a common sense way. We've got a 100 centimeter cube solution of 2 mole per decimeter cubed ammonium chloride. It really doesn't matter what this substance is, because I know its concentration. I'm adding 900 centimeters cubed of distilled water to it. Now you might think to yourself, well, that means I'm going to have a litre or a decimeter cubed now, and that's going to be 10 times as much as I had before. So the solution is going to be 10 times more dilute. So I should find that this is going to be 0.2 moles per dm cubed. But let's just do it using this formula, in case we can't do things like that in our head, and so that we can be clear about what C1 and all that stuff is. So my original volume is 100 centimeters cubed, so C1V1 equals C2V2, original volume 100 centimeters cubed, original concentration 2 moles per dm cubed. Doesn't really matter if they're in the same units now, as long as I remember that whatever volume I'm putting in here, my other volume is going to have to be in the same units as that volume, if you see what I mean. So here I'm going to go for 2 as my concentration, multiplied by 100 centimeters cubed is equal to, I'm asked to find the new concentration, that's C2, multiplied by V2, which remember is not this, but it's the sum of the two, so that's going to be 1,000 centimeters cubed. So C2 is equal to 100 divided by 1,000 multiplied by 2, and that's just 0.1 of 2, which equals 0.2 moles per dm cubed. And as I say, it's fine if you can do it in your head, but if in case you're going to make any mistakes, which you might well do, it's always wise to show all your working in a test or an exam, because then they can award you some marks for things that went right before they started going wrong. Okay, that's it for this particular film. There's only one more film from the quantitative chemistry topic. Hopefully you know the units of concentration now and all the other things that we've covered in this film. If any of it didn't make sense, come and ask as soon as you possibly can so that you can get some practice done as soon as you can. And if you've got any questions that you don't want to come and see me about but you want to ask, then please feel free to comment on YouTube.